My name is François Birgand. I'm an associate professor in bioanalytic engineering department at NC State University, and I work on water quality and ecological engineering. So our goal in our team is to improve water quality, just like many of our faculty here. There are many ways of doing this. One way is to capture water, treat that water in what we call treatment systems, and release it back. So many treatment systems have been actually invented in our department, including controlled drainage, bioretention cells, stream restorations, and so on and so forth, right? And in fact, using the existing technology, we've learned enough of these functioning, how the systems functioned, to actually follow a concept that they developed in Iowa. If you build it, they will come. And indeed, we've built a lot of treatment systems and a lot of improvement. Now, the problem is that they remain as a black box where we don't really understand how they function inside, and second, as a consequence, we're not sure how to improve them. This is where we're trying to come in. So one way to do that is actually to track the fate of pollutants in the treatment system and calculate kinetics, from which we can calculate processes, then we can try to improve these processes, okay? Well, that would be relatively easy if our treatment systems would receive water at a relatively constant flow. Well, this is not the way it works. It goes at pulses. Water just comes in our systems very quickly because it follows rainfall, and as a result, the previous technology just wasn't able to actually capture things like this, all right? So, what we've done is that we have heavily invested into new water quality sensors that allow us to capture in time and in space the variability of concentrations, from which we can actually start tracking the pollutants inside the treatment systems, and therefore track their fate. We can calculate kinetics of these systems, of the processes that apparently are stripping the nutrients out. And so what we can do is that then go back to the processes and propose things such that these processes might be triggered a little bit. So one of which would be, if you wet and dry bioreactors, maybe the denitrification efficacy will be a lot higher. And this is what we've been trying to do with Brian Maxwell right now in his PhD. Okay, so once we propose these processes, then we can improve the internal functioning and therefore the overall efficacy. And we do that with a lot of collaboration with faculty in our department.